My field of research is millimeter wave and terahertz techniques, meaning that I and my research group in Helsinki, we are studying electromagnetic waves, very short ones, from few millimeters to sub-millimeter lengths. And in frequencies, we are talking about frequencies like 60 gigahertz to 1 terahertz. Giga means 1,000 million, and tera means million. So those are the quantities, how high frequencies we are talking about. And so because we are engineers, we really study the technology. We study antennas, circuits, receivers, transmitters, measurement techniques. I have a group of about 10 researchers, postdocs and doctoral students there, and we have developed the different things. Maybe I mention a couple of them. We have, for example, established a hologram-based antenna test range. It's our invention. And hologram is what you know in bank cards, etc. But now we are using it for radio technology at terahertz frequencies. And then we have developed many kinds of antennas, lens antennas, leaky wave antennas, and for example, dielectric rod waveguide antennas. And that is an important area because I'm doing also that research here now. This millimeter and terahertz technology, it can be used in many applications like high capacity, high speed communications, imaging, different kind of imaging, for example for security or let's say medical imaging. It is used for remote sensing of the atmosphere and also to the Earth surface, especially from satellites. And of course, radio astronomy was the first application where terahertz techniques was used. So there are many interesting physical phenomena in the universe which we can study with these techniques, terahertz techniques or millimeter wave techniques. But there are also many, I would say, future applications where we will use it. For example, the automotive radar, which is already today at millimeter waves. It will, at millimeter wave frequencies, it will become very common and it will go to higher frequencies so that its accuracy, its imaging capability will get better. Here we are trying especially to develop new kind of terahertz sources. This terahertz technology, it is in that sense immature. Microwave technology is very well established, very well known, and so is optical technology and also infrared. Now terahertz is in the electromagnetic spectrum between these frequency bands, and it is immature. And for example, there are no good or let's say easy to use terahertz radiation sources. So now we have combined our forces from this university, UC3M and Aalto University, and actually there are others like University of Erlangen in Germany in our team, and we are trying to integrate so-called photomixer and a dielectric rod waveguide antenna to make a highly directive terahertz source. Of course, such things have been tried to build already before, but now our research during my stay here at UC3M is especially to integrate this photomixer with this dielectric rod antenna, because previously it has been done with dielectric lenses. but there are some problems, and now we try to do it better. I have some materials, so maybe I could show you the basic idea what it is. So we have previously this kind of situation where there is the photomixer, two optical or infrared laser beams are let's say focused to that photomixer, and then a high frequency terahertz current is created, and there is a small antenna element, and that then radiates towards the lens, and then that radiates further away the terahertz beam. Now we are trying to do a different kind of more focused beam with this new type of antenna. And so this is my main research, but there are a couple of other things, namely the National Radio Astronomy Observatory, JEBES, needs a new very wideband antenna feed for their telescopes because they are participating in international very long baseline interferometry measurements. And for that reason they need a wave antenna feed for 2 to 14 gigahertz. That's a big challenge. So we have created something, and actually here is an example, a very first prototype of a very old invention, basically. This is so-called Dyson antenna. Professor Dyson invented this kind of antenna, which is a conical logarithmic spiral antenna. Dyson invented this more than 50 years ago. Our challenge is to build this now for these short microwave frequencies, and this is a big challenge, but let's see how we will do. And then the third area where what I'm doing here is that we are writing a book on terahertz technology, semiconductor terahertz technology. And this idea to write the book actually comes from this Cátedra de Excelencia program, because there have been before professors interested in terahertz techniques here, and then a large international group of researchers have been created this way, I would say network in different countries and even different continents. And now this group, this network is writing the book.